simplify each expression using the zero exponent rule of exponents, which just says if I have a base that's positive not equal to 1, if I raise it to the 0 power, that's equal to 1. That's my zero exponent rule for exponents. So in the first case, we have c cubed divided by c cubed. Whenever you divide with a common base, you can subtract the exponents. So I now have c raised to the 3 minus 3, which is c to the 0, and that would be 1. For part B, we have negative 3 x to the 5th divided by x to the 5th. So I want to realize that I will rewrite the negative 3, but the common base of an x is in the numerator and denominator. Since I'm dividing with a common base, I can subtract the exponents on the x only. So x is raised to the 5 minus 5. This means I have negative 3 times x to the 0. So now I have negative 3 times, and x to the 0 is just 1. And negative 3 times 1 is negative 3. On part C, I have the base of j squared times k raised to the 4th, divided by a product, j squared k times the base j squared k raised to the 3rd. Now notice I do have a common base, which is j squared k. So I'm going to leave the numerator as j squared k raised to the 4th. In the denominator, I'm multiplying by a common base of j squared k. When you multiply with a common base, you can add the exponents. That'd be 1 plus 3. So again, in the numerator, I have j squared k raised to the 4th over what? J squared k raised to the 4th. Now I'm dividing with a common base, so I can subtract the exponents. This gives me j squared k, and that base is raised to the 4 minus 4, subtracting the exponents. Well, 4 minus 4 is 0, so now I have j squared k raised to the 0. And again, if I'm raising j squared k to the 0, then the result is 1. Thank you.